Yes, hello children. Now the continuation of the atoms. In that energy level diagram you can see on the screen a diagram which represents the total energies of electron in different stationary orbits of an atom, which is called energy level diagram, we can see. And an electron can have any total energy above that electron value, which is equal to 0 electron volt. In such a case the electron is free. And from you may see that the origin of various series of the hydrogen spectrum, which Lymer series, you can see the Lymer series, that is when an electron which jumps from the higher energy level to the first level, we get Lymer series. Then as we said already, the series lies in the ultraviolet region, and we said that V, which is equal to R within the bracket 1 by 1 square minus 1 by n2 square, right? So Palmer series, next you may observe the Palmer series, that the electron which jumps from any that higher energy level to the second energy level, the second n, which is equal to 2, in that level it jumps. This series lies in the visible region. So these and all already we have seen as the derivative part. So with the help of the diagrammatical, it will be very useful for you. And you may see that we can say 1 by 2 square minus 1 by n square. Okay. Then next one is that Pascal series, that in that n1 which is equal to maybe the 3, right? So this series which is lies in between, yes, infrared region. And see that the bracket that is on this series is also in that infrared region. That is n1, which is equal to, we can get it from that fourth region, that orbit, to n2 we can see the next neck. That means what? 5, 6, 7, like that it is coming. So the formula, how it will be modified? V, which is equal to R into 1 by 4 square minus 1 by n square. So in that n2 square we can apply any that orbit, 5th orbit or 6th orbit, you will get the value for that bracket series. So next one is the P-Fun series, that is you may get, that is n1 which is equal to 5, then n2 that value 6, 7, 8 value, that is for infrared regions of that little far away from that regions, that same region but little too far, right? So this is the diagram of the energy level diagram, you must know, right? So the next one is you must know about the limitation of the Bohr's atomic model also. See, this model is applicable only to the hydrogen or hydrogenic group of atoms, we can say, and we cannot be extended to even 2 electrons atoms such like helium, like any other atom. And this model is also unable to explain the relative intensities of the various frequencies emitted by the hydrogenic atom. Right, we can see one by one that points which we have seeing on the screen. The excitation energy. See, the term excitation energy, which gives the atom, if suppose an atom which is defined as the energy required by its electron to jump from the ground state to any other excited state. So we can say that the E2 minus E1, which is equal to minus 3.4 minus of 13.6, then we will get 10.2 electron volt value for first excitation energy, right? So what is excitation potential? The excitation potential, which is the minimum potential which provides an electron energy that is sufficient to jump from ground state to any one of the higher state of the point, that excitation potential, we can say 10.2 electron volt by E. So you will get 1 or 2, whatever it may be, you will get the value like. So ionization energy. What is ionization energy? Which is nothing but the minimum energy which required to knock an electron completely out of the atom, we can say, and that is called the ionization energy. That means the energy which is required to take an electron from the ground state to outermost orbit. So maybe outermost we can take n value which is equal to infinite, right? So we can get what it may be the ionization energy. You can also say that is E infinite minus E1, which is equal to what? 0 minus 13.6. Then you will get 13.6, obviously the ionization energy of the electron. The ionization potential, which is nothing but what? The minimum potential which would provide an energy to just remove an electron from atom, which is called the ionization potential. See, de Broglie's weaves of the Bohr's second postulate. See, it states that the angular momentum of the electron orbits around the nucleus is quantized. That is, we know that L, which is equal to nh by 2 pi. Why should the angular momentum have only those values and or integral multiple of h by 2 pi? Why not we should not keep the values of integral multiples value? So the physicist, he said that de Broglie explained about for this question after some years after, and Bohr proposed his model. We know that when a string is plugged, a vast number of wavelengths are excited, right? However, only those wavelengths survive which have nodes at the ends. It means in the SHM we have seen in that class 11 in SHM, SHM2, in that about these values of wavelength, all that you may have studied, nodes, antinodes values. It means that in a string which standing waves are formed when the total distance travelled by the wave down the string and back is one wavelength. Two wavelengths or any integral number of wavelengths is possible. So that we can say 2 pi r n, which is equal to n lambda. So n value 1, 2, 3 up to that infinite, you know that the lambda which is equal to h by mvn, right? So L which is equal to nh by 2 pi, we can say that mvrn which is equal to nh by 2 pi. Got it? Now what are the limitations of Bohr's atom model? We have already said that, and some of the points you can get it through this. See, the Bohr model is applicable, as already we said, the hydrogenic atoms only, because of it cannot explain for even two more electron atom which is there like a helium, right? See, the difficulty which lies in the fact that the electron interacts not only with the positively charged nucleus and also with the electrons it should be, so that he is not given that to the extent that he didn't study and derive for that particular things. And while Bohr's model correctly predicts the frequencies of the light emitted by only the hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies in the spectrum, as we said. Thank you, children.